Hello and welcome to another R Labs tutorial. In this video we will learn how to create functions in R. So first of all, what is a function? Well, a function essentially takes an input, performs a series of commands, and then gives an output. And there are many built-in functions in R, as you can see here, some of which I'm sure you have already used. But there are some tasks that we might want to perform that do not have associated built-in functions. So for example, if we have the radius of a circle, we might want to find the area, which is given by pi times radius squared. So if we have a radius of 1, we would have to type in pi times 1 squared. And we have our answer. Now if we wanted to, we could repeat this bit of code over and over again, experimenting with different radius values. And since this is a pretty small bit of code, it's not too bad to rewrite it multiple times. But it would be even nicer and might limit the number of coding errors made when recopying if all I had to do was type the word circ.area, for example, and then input the radius of the circle whose area I would like to know. This sort of shortcut would be especially handy if the code producing such an output was a lot longer. But as you can see, when we type in circ.area1, we don't get 3.141593 like we did when we calculated the area manually. We get an error because circ.area is not a built-in function in R. But if we really wanted to, we could make a function that is able to take a circle's radius and return the corresponding area. Now when making functions in R, there is a general structure that must be followed. We come up with a name for the function, which could be anything we want it to be. And then we have gets, and we write the word function. And then we have a set of round brackets where we specify one or more arguments. An argument is like the input. It's what the function takes in and transforms before spitting out an output. Then in between these curly brackets, we have the expressions, or the code for all of the intermediate steps that are done in order to get an output. And then we write the word return, and in round brackets, we specify what we want to be returned to the console. So with our area of a circle example, let's call our function circ.area. And then we have to write gets and function, and our input is going to be a radius, so we can put r in round brackets as our argument. I chose the letter r to represent a radius, but the function doesn't care what the argument is called as long as you are consistent when referring to that particular argument within the function. Okay, next I'm going to make a formula by assigning the expression pi times r squared to the variable area. And then we want our function to return area. And we are done. So now we can say, what is the circle's area when we have a radius of 1 or 5, and so on and so forth. And you can save all of the functions that you use and build a sort of toolkit. And then when you open up RStudio to start a new project, you can just find the tailor-made functions that you will need from your collection, run them each once, and then you're good to use those functions for the whole session. So functions prevents recoding common routines both within sessions and between sessions. Now, as always, there are several variations of this general form. First of all, it is not necessary to assign the expressions to a variable within the function. We can simply write the appropriate expression within the return function, like this. And we can see that it still works. And in fact, the return function is not absolutely necessary either. Without explicitly returning an object, the function writes to the console the output from the last expression evaluated within the function. In this case, there is only one expression, so we know that its output will be written to the console. But we will see in a few examples that we can get multiple expressions within a function. Now, personally, I find that functions are most understandable and most tidy when they follow the first general format that I showed, where expressions are assigned to variables and where the return function is explicitly used. Now, instead of specifying one value like 1 as the input, we can specify a whole vector of inputs, and the function will be applied to each element of the vector. So for example, we can make a vector x containing the numbers 1 to 5, and then we can determine what the area of 5 different circles would be if these 5 values were radii. Now you can also return more than one output. So for example, you can return the circle's area and circumference when given a radius. So we can build another function, we'll call it just circle, and again radius r is the argument. And now we're going to have two different expressions. So area gets the expression pi times r squared, and circumference gets the expression 2 times pi r. Now to get both of these values printed to the console, we can do a number of different things. First of all, we can return a vector using the concatenate function. And this vector contains both outputs, area and circumference. Now I have used area equals and circumference equals here in order to give titles to the values of area and circumference respectively. And we can see that that worked pretty nicely when we used a radius of 1. But if you input a vector, getting a vector as an output can sometimes be a little bit messy. So to demonstrate, we can use our vector x from before. And you can see that it worked. There are indeed 5 area values and 5 circumference values, but it just looks a bit crammed and messy to me. So let's try returning a list instead. And again, area equals and circumference equals are names for the different elements of the list. And we can input our vector x, and you can see that we get 5 area values returned first in the list, and then 5 circumference values returned next. Now if you don't like this either, you might prefer a typical data frame. So here's the same code as before, but now we're going to return a data frame. And we'll input our vector x, and you can see here that we get a nice looking data frame with the 5 area values and 5 circumference values associated with the elements of our vector x. Now if we want to store these output values for later use, no problem. We just assign this command here, circle x, which is responsible for actually writing the output to the console, to a variable. So I've called the variable output here, and we can call up that variable, or we can call up the values in one column, like the area column of the data frame, and so on and so forth. Now what if instead of getting a bunch of numbers returned to us, we want to visualize the relationship, for example, between radius and area? Well, we can return a graph very easily. So here we will create a function called graph, and again it is a function of r, radius. We define the relationship between radius and area, and then we return a plot with r on the x-axis, which is going to be labeled radius, and area on the y-axis, which is obviously going to be labeled area. And we input our vector x, and there we go. So we have talked about how we can have multiple outputs, but I should also mention that we can have multiple inputs as well. Let's put aside our area of a circle example for now, and instead we are going to make a function that tells us the volume of a cylinder. So for this type of problem, there are 2 unknowns. We need to input the radius of the circles that form the top and bottom of the cylinder, and we also need to input the height of a cylinder. So we'll make another function called sil.vol, and as inputs we have r representing the radius and h representing the height, and we define what the volume is, and we return this vol, and we can test to see what volume we get if our radius is equal to 1 and our height is equal to 2, for example. And there we go. Now, particularly when working with functions that have multiple arguments, it can be good practice to name the arguments when calling a function. So instead of just typing sil.vol12, I could have written sil.vol r equals 1 and h equals 2. And you can see that we get the same answer. Naming the arguments can simply help to avoid inputting the values of the arguments in the incorrect order. But as we have seen from all of the previous examples, it is not at all a necessary step. Now, I should also mention that it is possible to set default values. So for example, when writing the sil.vol function, I could have written sil.vol gets function r equals 1 h, and then we define the volume as before, and return vol, and close our curly brackets. So in this case, 1 is the default r value, meaning that if an r value is not specified when using the function will assume that the radius is 1, and will proceed to complete the function with this assumption. So we can write sil.vol r equals 1, h equals 5, and we get 15.70796. But if we don't specify that r equals 1, we get the exact same answer because the default value of r equals 1 has kicked in. Thanks for listening to this RLabs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.